Okay. Okay, we will start today's lesson by some simple quadratic equations. Okay, so my first step is, let me see if you can understand this basic expansion. Now, if you notice, uh, if you expand on the left hand side, you will actually get this. Okay, and this is quite rudimentary, as we all have learned this in high school. Now the same thing, if I replace this 3 with another variable, for example k, if you notice, you will have this expansion. Now all I want to do is pay attention to this. Now there is a unique relationship between this 2k and this k squared, just like there will be a unique relationship between this 6 and this is 9. Basically this 9 is actually 6 over 2 squared. That will give you 9. So this k squared will be 2k over 2 squared. That will give you k squared. So just remember, there is a unique relationship between the second coefficient like this one here, and the third coefficient. Okay, now if that is understood, how would we go about solving this using that similar technique as we have learned in other lessons on this? Now, first of all, pay attention to this 8, the second coefficient. Is there a unique relation, the similar relationship that we talked about just now? Is 8 over 2 equals to 5? And it's not. So what we will do is we will take this minus 5 and bring it to the other side. Okay? So it will look something like this. Now on this side, we will like to replace with what we like. For example, plus 8 over 2 squared, and here also the same thing, plus 8 over 2 squared. Do not forget, you can't add one side of the equation without adding to the other side to balance up the equation sign. Okay, if that is true, so you'll end up looking like this. Now, if you notice on the left hand side of the equation, they are all well balanced. Okay, there is a relationship between the 8, or rather the second coefficient, and the third coefficient. There is this unique relationship that we are talking about. That means on the whole entire left hand side of the equation can be squared. So you will have something like this. Now, after modulating this, you know that this whole thing can be simplified to become 21. So it will look something like this. Now, I can solve for x simply by first taking the square and moving over to the other side, and it will look like this. Okay, and then as you know, the plus 4 can be also moved over the other side. And therefore, we have solved this equation. Now, similarly, I can get back to something a bit more complicated like this algebra question. Now, I would like to solve this equation with a, b, and c. Now, the first obstacle for this is that I have a variable a. This variable a is hindering me from doing the method that we discussed just now. So what I will do is I will divide this side with a, this side with a, this side with a, and this side with a. If you notice, this a and this a cancels out. Obviously this would not make much difference, and we will work with the others. So you'll end up looking something like this. Okay, now same concept. Look at this second variable coefficient and the third coefficient. There is no unique relationship. So what I'm trying to do is I'll move this over this side to aid my simple factorizing. So what I did was, once again, I took this, I divided by 2, and I squared it, and I do the same thing over here to balance my equation. So it looks balanced, and this is just the first step. Now the next step, what happens is I have this. I simplified on my what is on the left hand side, and I got over here. Now all I have to do is combine this into a single denominator fraction. Okay, so my single, first of all, I know that's a here and here, but before that I could rearrange my equation to look more more friendlier to the students. So I rearranged it this way, and now I'm going to go and proceed to combine these two into a single function. So it looked like this. Okay, very simple, no problem. Okay, then my next procedure would be is to see whether I could remove the square by bringing it over to the other side. I will end up having this equation. Now of course, if you notice, I could simplify this 4a squared under the square root sign. So I will have something like this. Now this is quite straightforward. I'm just going to bring this to the other side, and I will have this equation. Now if you notice, there is a 2a here, there's a 2a here, and a 2a here, so I can make it into a single fraction looking like this. If you notice, this is actually the quadratic equation formula. Okay, with this I would like to end my